In today's morning class, I have discussed about the computing, approaches that we have basically in network systems. So, as we discussed, we have basically three computing systems or computing methods that we can use to do the computation of data based on the requirement. So, when we talk about cloud computing is mostly used if you have like data that needs to be processed with um, high accuracy, and also if we want to manage large bulks of data which cannot be managed by a small scale edge processor or a fog processor. So if you have large bulks of data, sometimes you can go for a cloud computing approach. However, like if you consider other scenarios where we have an IoT network at the edge of the network, if an IoT network is connected to the edge of a network, then sometimes we will have some sensors uploading their data to the edge point uh, uh, with high frequency, and the data is we need to do the computation on the data very fast, so that we can give some useful data to the customers who are connected to the network in that local area, such that we can give some updated information about the environment without much delay. So in cases like that, we will need edge computing. So we'll discuss about those specific cases where we need edge computing, and also fog computing, and so on. So fog computing is something intermediate between cloud and edge computing. So in the morning class, I discussed about how we can discuss about the different computing methods. So starting with the cloud computing, in the last class, we have discussed up to this point, where we stopped at the cloud services and the three key service models that we have, which are basically infrastructure as a service, or IaaS, platform as a service, PaaS, software as a service, SaaS. So these service models can be considered under the cloud computing services, and these three services are differing based on the different components that you can control in the cloud infrastructure. If you have an infrastructure as a service, so if you have obtained infrastructure as a service into your, if you have purchased these services, infrastructure as a service, then you have the full control. Most of the control over the cloud infrastructure. Some portion will still be controlled by the cloud infrastructure. However, like most of the cloud infrastructure will be under your control. So let's take an example in here. So suppose you are starting a company of your own, and in there you want to develop an infrastructure that gives services to your customers. So if you want to build an infrastructure according to your own preferences, then you need to customize the entire thing, right? You have to customize the operating system that you use, right? The platform that you use, and then you have to customize the softwares that you use. So based on those requirements, you will be going ahead with this infrastructure as a service model. So you will be given the ability to customize the software of the platform. And also you can have the control over the operating system and the middleware softwares that allow you to customize the operating system as you want, and choose the one you wish, and then use those systems, operating system, and the middleware softwares to access the necessary services that your company needs. Like based on your company's services, you might need to access different other softwares that are available in other cloud servers, maybe, and in other locations in the network. Then you might need this middleware software to access services which are available in other parts of the network. So basically, therefore, like if you're having an intention of creating a customized in cloud infrastructure, then you need to go for the infrastructure as a service model. In there, you will be building these softwares on your own. So the building of softwares will be done using the components, application component and the data component, where you will be developing an application, and also you will be customizing the data. You will be processing the data actually, and input the data to the necessary the necessary and the specific application in consideration. So if you have the control over the software layer, then you can build the softwares on your own. And also you can control like the software, like the hierarchy of the softwares that are used in your system. So the operating system also you will be having under your control. You will be having the middleware also under your control. So with all those under your control, you are now able to flexibly control the infrastructure under your preference. Then if you have like an intention of not really like building the infrastructure of like as you need, but you want basically a platform to develop softwares. So if your company wants a platform to develop a software, then you can use this platform as a service model. So with this one will allow you to develop softwares on top of a already available platform. So already available platform will be allowed, will be controlled by the cloud, and also other like components such as the like networking components, hardware component of the cloud, the storage, virtualization components will be controlled by the cloud. So basically, if you're having the need to control and build softwares, then you can use the platform as a service. So in there, you can build softwares as you wish, and you can give the services to your customers. So the building of the software can be done on top of this platform, and you can, deliver the services through the software you develop to the customers. Also, you can install these softwares that you develop in other platforms also. So if you have any questions, please let me know. Also, I mentioned to you about the controlled sections only, but in all these different service models that you can use, there are certain types of services that are provided by the cloud itself, such as networking, hardware, storage, and virtualization. So which means that the cloud is enabling you to perform the networking functions by creating the connectivity between the cloud server and the other network components in the network. Also, the cloud server will allow you to access the internet and also build the local area network. Also, then it also provides you with the hardware, which is like basically the servers, which you can use to build the necessary softwares or the infrastructure as you need. Also, it provides you with the storage space that you require. So there could be some specific storage space that it allows you to operate on and use. Then also it provides you with the virtualization softwares. So the cloud service provider will provide you with this virtualization software. So the importance of this virtualization software is that once you have those softwares, it increases the flexibility of using a certain space in the cloud server under different purposes. You can use this, like the same space you can use for different activities and different um, applications. What I mean by that is that if you have different applications, uh, and if you have different customers to serve at one instance, then you can divide this space in the cloud server into three, and then you can allocate three virtual machines to address the concerns directed by those customers. So these virtual machines can address those challenges. So rather than addressing customer one by one, when you have these virtual machines which are working simultaneously, you'll be able to address the challenges or the customer requests separately but simultaneously. So this will be able to increase the efficiency of your system. So, the efficiency in terms of providing the necessary quality of service or the service to the customers. So the customer will be served within very short time. We will be able to provide services for many customers at the same time. So virtual machine creation and those, uh, I mean, uh, service provision in separate virtual machines can be done once we have this virtualization software installed. So with the software as a service, we will be having basically a control over we won't be having any control over all the cloud infrastructure, but you will be able to use all the available resources that are provided by the cloud infrastructure. In software as a service, the user will be basically using a certain service. The user will not be doing any kind of implementation on their own. So the user is able to get the advantage of all the cloud services and achieve their tasks. So in the real world, the applications of infrastructure as a service can be seen where we have this Google services that provide infrastructure as a service to many customers. And such companies include Amazon, Microsoft, IBM, so on. So there are some experts that manage this infrastructure, and they will be able to uh, manage and do the necessary development in the infrastructure. So anyway, like what we give as infrastructure as a service will only be able to be managed only if there are some experts who know this network infrastructure. So we need some network specialists and experts to manage those infrastructure services that are given to us. So these are the companies that give those services, like Google, Amazon, Microsoft, IBM. Those are the companies that give those services to the customers. So the customers who receive these services will have to develop the network on their own. So once that happens, the experts have to manage. There should be some experts to manage those infrastructure. So it's like, although you are given a service, if you don't know the knowledge to operate, you cannot really get the use out of it. So if you consider the platform as a service, it requires less expertise over the app. Over the cloud infrastructure. In there, actually, you are basically focusing on developing, apps, softwares on top of a platform. So in there, actually, we'll be using basically some platforms provided to us, to you, such as Google App Engine, Heroku, and so on. So these are kind of like available tools, like platform that allows you to build a certain app on top of the platform. So these are the platforms that you can use. So these kind of platform allow you to build the software based on your preferences. You can customize the software and build the software based on your preference. And so in here also you need some experts who can build the software. If you take the software as a service model, it will basically be the model where you can use a service directly without any requirement of hardware and software. So these include Google Drive, Dropbox, Gmail services. So these services can be directly accessed by customers without having to install any software or hardware in their computers. However, the problem in here is that the customers who use these services are at a risk of exposing their data into these softwares. So because of these into these application domains, and therefore like those data are stored, then there could be some intermediate people who can access this data. So there's a security risk involved with this software as a service model. So when we take these IaaS, PaaS, SaaS models, once you go down in the order, or like from infrastructure, platform to software, the ease of use of these service models increases. So the knowledge that you need to use these services actually decrease, but the ease of use of the services increases. However, like if you know the stuff, you know how to build the network architecture and build softwares, then once you go up in this direction towards the infrastructure as a service, then it actually increases the flexibility to you to like customize the infrastructure based on your requirement. So based on your knowledge, you can actually customize the service based on your requirement, and then you can make it more uh, like uh, make it more flexible for your requirement. So any questions up to that point? So I'm going through the sections that I have done previously in the online class. So you can also go through that later as well. I'm just covering that now just to make a beginning to the today's session. So basically, after this discussion about service models of cloud computing, which I discussed in here, I have discussed about the different computing methods. So basically, edge computing, fog computing, and cloud computing. So by now we have discussed about the cloud computing scenario, and we have next to discuss about the edge computing and then the fog computing scenarios. So when we discuss about the um, the need for these three types of computing, we can consider an IoT network, an application where we require uh, IoT devices to be connected to a certain local access point. So if we consider this as a local network that we have with multiple sensors connected to the network access point, such kind of cases will lead to a lot of data getting uploaded to the access point. So if the data is getting uploaded with high frequency, then there could be a large data traffic at this edge of the network. So edge of the network is the point, or it's actually a location where the local area network is ending and a new network is starting. So edge is defined as the point where the local area network is ending and a new network is starting. So the server, we can install a server at the edge access point. Then we can do the computations at the edge of the network. If we can do the computations there, we'll be able to reduce the latency of transmitting our data from this edge server or edge point to the cloud server. where you will be doing the data processing. So the delay that is occurring once you are transmitting the data through multiple network components to a cloud server is high if it is a very time sensitive application that you are considering. So if you want to like give back the feedback to the customers who are connected to the IoT network, then you need to have real-time updating system. So for the real-time like features, you need to do the computation at the edge server level. And then you can have less delay in providing the feedback to the customer. So because of all those things, edge computing has come into the picture where we can do some computation over at the edge. So in cases where we want low latency and then real-time updates, we can use edge computing. So in so when we consider about the edge computing, we can apply it for scenarios which involve with manufacturing facilities. So in scenarios where you have manufacturing facilities that use robot robots and where you need to control robot arms to achieve some task, there we can use edge computing to make decisions and also like control the robot arms uh, while also predicting if the operation of the robot arm is going smoothly as expected. Also, it can also control and uh, you know uh, identify the operation of the product line in the manufacturing area. So by doing that, we can improve the performance of the product line and reduce the amount of faults that are there in the product line, for example. So image processing can be another application area where edge computing can be used. So image processing is another area that you can use edge computing for, where actually uh, you will be uploading some images to the edge server, and the server will be doing the computation at its level using some image processing techniques. So after doing that, the edge server will give some feedback back to the devices who are in the network. So image processing can be used for scenarios uh, and for scenarios that are at the edge of a certain network, and that can be used through edge computing technologies. So therefore, like we can combine edge computing and edge image processing techniques for certain applications. So normally edge server is a very powerful computer in the network, is in the local area network. So edge server is a powerful device. It is able to do data processing efficiently and also enable network connectivity between the devices. And also storage, memory capacity of those edge servers also we can consider as considerably high. So what we like have in here is a server, edge server, which is kind of resourceful that can do data processing, that can enable network connectivity between devices, and also that can um, also store large amounts of data. I mean, considerable amount of data uh, enough to store the data that are uploaded by the local area network. There are some specific devices which are connected to the local area network, and the data that are uploaded by those local area can be stored in the edge server. So the edge server will be kind of, designed in such a way that those, the data can be like stored in those edge servers properly, and there will be some memory also, and the memory will be able to retain some useful data in the memory. with the edge computing, also another aspect comes where you have multi-access edge computing. The difference with the normal edge computing is that with the multi-access edge computing, you are basically using the assistance of mobile telecommunication systems, such as using, the cellular communications, where you will be using the infrastructure like base stations as the connecting point of the IoT devices. So once the data are uploaded to the base stations, the edge server will be installed in the base station based processing unit. And then unnecessary computations will be done at the edge server, and the edge server will be able to give back the feedback to the devices. Also, the network infrastructure will enable the communication to happen very smoothly because the network infrastructure has the ability to communicate with sensors even at large distances, such as 1.5 kilometers away from the base station. So even though sensors are placed in large distances or long distances away from the access point, still the network infrastructure is able to access them. So rather than using some short-range communication technologies such as Wi-Fi, Bluetooth, we can use the cellular architecture and the cellular communication technology to communicate with the devices who are connected and with less connection failures. So once the connection, strength is high, then you can have frequent communications with the IoT devices successfully. After that, the data can be uploaded to the core network and then to the internet and to the cloud server. So the cloud server also can monitor the data of the IoT network and make some decisions that can improve the performance of the IoT network. So apart from the edge server, the cloud server also can help in making some improvements in the IoT network. So with this multi-access edge computing technology, we can reduce the latency of the communication and up to a range of about 10 milliseconds, and we can address. Uh, we can consider scenarios where we have like mobility of the devices, which means that the devices are moving also, we can still have connection with the network infrastructure, and therefore we can still have edge computing and other computing methods, and we can do the necessary processing of the data. Then real-time updates can be given to the connected devices, such that the connected devices will get some useful information very quickly from the network infrastructure and make their own decisions based on the data that they receive, right? So consider a scenario where we have vehicular network. That means that each of these devices that are connected to the network infrastructure will be vehicles. So if the vehicles are in a traffic, then if we can enable edge computing in this scenario, then we can give some timely updates to the devices or the vehicles saying, okay, this is the traffic that is there in the road. So if in this road, there's some traffic like this. In another road, there's some less traffic. So you can use the other road, something like that. Also, if there's some accident that happened in the area, you can tell that to the devices, the vehicles as well. So by providing some frequent updates back to the vehicles, then the vehicle users will be able to get updated information about the network. So if they had to send the data all the way to the cloud server and get the updates, sometimes there could be a high delay in getting the necessary updates. So therefore, the delay must be reduced to give quick updates to the vehicular users. So the vehicles can quickly get updated data regarding the data traffic in the road. So in order to reduce those latencies, edge computing can be proposed as one of the solutions to the network to provide real-time updates and also provide the update with low latency. And also considering the mobility of the devices, we can provide that service. Also, we have this mobile telecommunication services that are enabled in this scenario under this multi-access edge computing scenario. So in that scenario, since the cellular communications always have a high data rate when you compare with the other communications. It has a high data rate in the range of about megabits per second and gigabits per second. So with that high data rate, the communication can be done in a very successful manner with the users. And also we can provide like large amounts of data to the users if needed. So I think that is regarding edge computing and multi-access edge computing. Any questions up to that point? So actually, I think I went a little bit, faster in this section now in explaining, I think, mainly because I have already covered this in the online session. So if you want, you can revisit that. I have uploaded that in the LMS. So the reason is that I need to, cover up the content for this lecture series. So I hope to start with the industrial IoT today. So with regard to these computing technologies, I have already covered the content in the online class. So I have discussed about the edge computing, fog computing, and cloud computing scenarios. And also I have explained about the differences between these three types of computing. So basically, edge computing is used for doing computations at the edge, and in scenarios, it is vitally used in scenarios where you want real time, you want to provide real time updates to the users with very low latency. And also, if you want to consider like dynamic environments, also, this edge computing is useful because the environment keeps changing very fast. Also, then fog computing is another computing technology. So fog computing will be done in an intermediate location in the network, which will do the computation of the data between the cloud computing and the edge computing locations. So fog computing location will be somewhere in between these two locations that are used for edge computing and for cloud computing. So the fog computing will be done, let's say, in an intermediate location where you have a fog server connected to one of the intermediate servers, intermediate network devices. So the fog server is connected to one of the intermediate network devices. So in such kind of cases, the fog server is able to assist in the data processing. And in situations where the edge server cannot do the processing alone, the fog server can assist in doing a part of the data processing in a kind of a faster pace, I mean, in a fast manner, and provide the feedback back to the edge network. So in situations where the resources of the edge computer is considerably lower, and then it needs more computation to be done, then those data will be forwarded through the network towards the cloud server. And in cases where the intermediate fog server can handle that data, the intermediate fog server will do the computation that is that should be done by the cloud server. So cloud, instead of sending the data all the way from the edge network up to the cloud server, the data will be stored at the fog server where the data will be processed. So the latency of the communication will reduce considerably once you send the data to the fog server to be processed. If the data, the delay in the data transmission is 5 minutes to the cloud server, then we can say that the delay for the data to reach the fog server is below 5 minutes. So therefore, the processing that will be done will also require some time. However, the feedback can be given more quickly than cloud computing when we use fog computing. So fog computing is done in an intermediate location in the network between the edge computing server and the cloud computing server. you will have a fog computing in the intermediate location. So fog server is also similar to cloud server. However, sometimes fog server might not have sufficient like storage space and the processing ability as of the cloud server. So basically, the processing unit might not be as powerful as the cloud server. However, like storage processing also can be done at the fog server. So any questions up to that point? Uh, by the way, like any updates regarding your project? Do you have any questions? Okay, can you mark your attendance? I will start with the industrial IoT today. In the next week, I will most probably will not be delivering this class, IoT class. I'm hoping to give you that time to do and finish your project if you haven't finished that one. So in the next week class, I might not be, doing the content delivery. I will allow you to do the projects. So in today's class, I hope to finish or just at least start the industrial IoT section, and then I will be able to continue with the section in the week after next. Okay, so thank you for marking your attendance. So I think I will start the section on industrial IoT. So industrial IoT is basically focusing on um, creating systems for industrial environments, creating IoT systems or IoT networks for industrial environment. So in that, actually, we will be focusing on, building IoT networks for very challenging environments uh, and not the usual consumer-centric IoT networks, which are used to, control like small-scale devices such as like doorbells, lights, like small devices in the house. So likewise, so we are talking about like more robust devices and controlling those devices. So in industrial IoT, the difference with the normal IoT is that in the industrial IoT, we need more robust sensors, processors, and we need um, those sensors and processors um, uh, to be included in a certain industrial scenario, which is concerned with manufacturing some items, or else developing some services for a logistics purpose, and also developing services related to healthcare, for example. So basically, like we are focusing on developing IoT networks for more robust, for more, I mean, require, we are hoping to develop IoT scenarios, IoT networks for more challenging environments that are available in manufacturing facilities. So some of the sensors that we use are given in this um, slide. So the sensors that we typically use are basically these kind of types of sensors. So these types of sensors, such as air quality monitoring sensors, flow monitoring sensors, temperature sensors. So these sensors are used in the manufacturing scenario, and they are typically very different from the normal temperature sensors that we use, normal flow monitoring sensors and other air quality sensory sensors. So the reason being that these sensors are more robust to the challenging environments that happen in the or occur in the environment in the industry. So the sizes of the sensors are also quite large. So the temperature sensor is quite large and it is more robust, so that these kind of sensors will be held without breaking for a long duration of time under drastic conditions. When we talk about the different microprocessors that are used or processing units that are used, there are like microcontrollers that are used in the industrial IoT networks that are driven by the IoT technology. So once you are considering IoT technology, you need to have some microcontrollers at the edge of your IoT network where the sensors are to in order to get the necessary sensor measurements from the sensors and act on those kind of data that you obtain. You can process the data that you obtain from the sensors and make decisions at the device level, or else you can upload the data to a certain centralized access point, and then you can get the feedback from the access point again. After that, so that is one. This is one example. You will be used Arduino Industrial 101 microcontroller to obtain and manage the data that we receive at a certain local network. And then we have also PLCs that are used in industrial environments, right? A programmable logic controller, right? So programmable logic controllers are used to like manage the different components in a product line. Then you are going to manage the functioning of the different uh, devices and the sensors that are fixed to the product line. So the PLC will also be able to be modified with Arduino microcontroller. So we can install the Arduino microcontroller to the PLC. We can enable the functions of both Arduino and the PLC and obtain improved performance from these PLCs. So standalone PLC might not be able to provide some functioning, but Arduino can improve the performance of some functions. Then Raspberry Pi assisted panels are also available for industrial, like performance monitoring of a product line. For example, so the Raspberry Pi is able to give like additional performance to these kind of panel based systems that work on giving data to the workers who are working in the industry. So the Raspberry Pi, as you know, is a very highly advanced microcontroller that is able to do high end computations. So those kind of processing units are therefore able to give more useful information to the user interface. Then we also can consider how these devices or the sensors in the industrial IoT networks are connected. So we can have a certain, like connection between the sensors and the PLC. The PLC will be able to get the inputs from each of the sensors. So in a case where you are connecting the temperature sensor will be connected to a certain unit, and then that unit will be connected to the PLC. Then PLC will be able to update the data to an access point, and then from the access point it will be uploaded to the cloud. So that is regarding the different devices or sensors that are basically used in industrial IoT networks. So basically, like
Uh,
basically the sensors and the processors that we are using in the industrial network were discussed. Any questions up to that point? So in comparison to the normal IoT, the industrial IoT will be requiring more robust sensors and processing units. So more robust sensors, processing units we will be using. If you take a production line with some products getting manufactured in the line, in the industry, then we can place some sensors in the production line to obtain different sensor measurements related to the product line. You can have a camera to obtain the camera images. Then you can have a temperature sensing sensor, then maybe humidity measuring sensor, and other sensors you can install in there. Using those sensors, you can get some idea regarding the production and the product quality. Apart from that, we can also have some devices installed on the side of the product line that will, like monitor the quality of the product. So if there's some fault in one of the products, those faulty products will be taken out from the product line. So such kind of machines can be added to the product line. Apart from that, we can also add some robots, or some kind of robot uh, a network of robots to help with the production line. So we can use these robots to move items from one location to another location. So there could be some circular robots that we can place on the floor that can move easily along the floor to another location in the industrial facility with efficiency, which means with low delay, and provide the products to another point in the factory. So these kind of devices can be integrated in a current industrial facility in the world. So we will have robots, machines, sensors. All these things will be included in a IoT or in an industrial facility. If we combine this if we combine the IoT technology to a manufacturing facility, then we will be having more connectivity between the sensors, machines, robots, and any other kind of devices which can be connected to a certain access point. So if we take this scenario into account, we can connect all these machines, robots, and sensors to a certain PLC, programmable logic controller. We can connect sensors to this programmable logic controller. So we can connect the sensors, right? Sensors. We can get the inputs from the sensors basically using the PLC. We can connect the sensor outputs to a PLC. So if I draw the sensors in a large dimension, then I will be able to show the sensor using this box. I will say this is a sensor. Then this sensor can be connected to the PLC using some lines, copper lines, or some kind of connection lines to the PLC. So whatever the temperature, let's say temperature sensor measurements are taken, those temperature measurements will be sent to the PLC through a connection link. If you have also the machines also can be connected to the PLC. So the machines that I mentioned in here, so such kind of machines also can be connected through wires or wireless methods to the PLC. So the machines also can be connected. Then also we can connect the robots through wireless links to the PLC. So the robots also will be under the control of the PLC. If we have a PLC at a certain local area, then we can control these kind of different devices at the end of each the PLC input. So the PLC is able to control multiple devices and also give commands to them or feedback to those devices. So the PLC, if the PLC is connected to these different types of sensors, then we need to have methods to differentiate the data that is uploaded by each sensor, machine, or robot. Apart from that, when we have a PLC like this, we also have the ability of extending this small network beyond this point to the internet and then make it an IoT network, right? So when we have the connection made to the network infrastructure through a certain access point, then we can connect to the internet. So we can connect our PLC to a certain access point in the industrial facility, and we can also connect a certain edge server to the access point. So if we need to do the computations really fast, we can send it to the edge server, or else we can send it to the network and to the cloud server, and then we can do the computations over in the cloud server. So in the cloud server, we can do some computations if the time is not a problem. If time is a problem, we can do the computations in the edge server, where we are sending the data to first. And then the data will be then processed, and some feedback will be given to the network. So in here, actually, that the PLC is playing a huge role. PLC is able to act as a an embedded system that can do many computations, right? The programmable logic controller can do high complex tasks, can do some processing of data processing part it can do, and then improve the computation at the edge. This PLC is able to do data like processing. Then it is also able to do data processing, it will be able to do. And then data forwarding, it can do data forwarding to the internet. Data forwarding can be done to the internet. So data can be collected through the sensors. Those data will be sent to the internet. So the PLC will send the data through the access point to the internet. Then any server which is like which is holding the data can be accessed to the internet, and then the data of the industrial facility can be obtained. Data forwarding will be done through the PLC, and then data processing will be done at the PLC, and it will control the different sensors, and then provide feedback to the sensors. So those things will be done by the PLC. And then, so that is basically regarding the basic setup of an industrial IoT network. However, like when we extend this bit further, we can also mention that this PLC enabled this industrial local area network can be connected to another infrastructure or another local area network as well. So if we consider this local area network as one network, just one network, if this entire thing is one network, then we can consider that we have the ability to communicate with another local network which has which is LAN number 2, let's say LAN number 1 and LAN number 2 we can have, and we can maintain connectivity between these two networks. That is also a possibility. Connectivity between two infrastructures is also a possibility with the industrial IoT networks. So suppose you have an infrastructure at Colombo, like one of the sites are in Colombo, and another site is in Hatton, let's say. So these two sites can also communicate through the internet, and therefore we can call that connectivity as connectivity between infrastructure, right? So that is something that is very special with the industrial IoT networks. Another thing that is special is that the communication between devices is also possible. So what I mean by that is, even though there are some specific differences between the devices and the types of devices, still we under the standards, the communication can be enabled between the different sensors or different devices as well. So the communication can be enabled between different devices, mainly because the direct communication between those devices or sensors can be enabled through short-range communications. So using short-range communication technologies, the communication link can be established. So communication link can be established using short range communication technologies, such as, let's say, direct communication technologies, such as like Wi-Fi, Bluetooth, or other specific protocols that enable direct communication link. Once you have the direct communication link, you will be able to connect with any of the other devices in the manufacturing facility. However, for that to happen, each of the transmitting and receiving device, they need to have the specific communication module installed in them, such that the communication can be done in that certain specific technology and through the certain specific channel. So the communication technology specific modules need to be installed in these devices, and then you can then have the direct communication link with the other device. Any questions up to that point? So if you have a remote like a user who's trying to access the information, they can connect to the internet and obtain the data regarding the situation of the industry through accessing the cloud server, which has the information regarding the industrial facilities. If there's a manager who's living in USA, for example, but wants to evaluate the manufacturing in Sri Lanka, then they need to connect to the internet and access the correct cloud server and obtain the data. So they will be able to monitor the industrial facility even when they're living in a faraway place. With the industrial IoT, we have some certain standard or industrial IoT has been actually proposed under a certain standard. So we call that Industry 4.0 standard. Industry 4.0 standard is the industrial standard that introduced IoT technology to be included in the facility, or the used to be included in manufacturing facilities. So the Industry 4.0 is the standard that started or that initiated the IoT concept in manufacturing facilities. Another like version is the Industrial 3.0. There are other versions of industrial standards, so we will discuss them one by one. The industrial standards have been proposed with the beginning of the Industrial Revolution in the late 18th century up to about 19th century. So this is going to be something related to the history of Industrial Revolution as well. So when you consider about the Industrial Revolution led to this, Industrial 4.0. So Industrial Revolution, which happened in the late 18th centuries, enabled this industrial standards to be proposed. The Industrial Revolution enabled all these standards to be proposed. So there were many industrial standards that were proposed while during the first stages of all the industrial revolutions. So there are industrial standards that are 0.0. So the industrial revolution led to the different standards, and industrial revolution, like because of the industrial revolution, we currently have these standards that are proposed. So industrial 0.0 corresponds to the first industrial facility using the printing press. So industry 0.0 standards means the kind of the initial development of a machine by Johannes Gutenberg. So the printing press, you know, the development of the first industrial facility for the printing press. So we have a printing. So initially we had the printing press based industry, which began in the very early or during the industrial revolution time. So this is known as the first step of developing an industrial facility. So with the first industrial facility came other industries. So other industries means like steam engine based, production. Those steam engine developed, the proposal or innovation of the steam engine led to mass productions of items in an industrial facility. So that is related to the industrial 1.0 standard. 1.0 standards relates to the era where we were doing mass production using the technologies of engines, motors, steam, and so on. So the steam engine enabled the production to reach a mass level and improve the efficiency of the production manufacturing. Then with the 2.0 standard, the industrial 2.0 standard came the electricity and steel manufacturing. So electricity and steel manufacturing, which means that with this standard, they had the electricity and also they had the ability of manufacturing steel. With those things, the improvement of the industrial product manufacturing also improved. So product efficiency also improved. After many years, the computer systems were enabled in the industrial facilities. So computer systems, right? So the computer systems were enabled to like automate tasks and also give like monitoring output to the centralized uh, you know processing units. So the computer system enabled industrial facilities can monitor the environment and give some warnings or data to the users in the facility. Monitor the environment can be done using computer systems. Then we have 4.0 version, right? 4.0, where we use the IoT standards or industrial, Internet of Things concept in the industrial facility. So IoT concept is integrated in the industrial 4.0 standard. IoT concept means the connectivity uh, addition to the network. So we are adding connectivity to the network. So basically, connection between devices to access point and from access point to the internet can be considered as a simple IoT network. So that connectivity with the internet, with the other network devices, with the other devices directly uh, can be uh, mentioned as the connectivity aspect. So the connectivity aspect of the industrial facility was implemented in this industrial 4.0 standard. Apart from that, there are other standards also that came, like Industrial 5.0. So the Industrial 5.0 is mainly focused on, developing cognitive technologies, which means that they are going to integrate, technologies related to artificial intelligence, then uh, cybersecurity, and then also they are going to integrate um, cyber physical systems. So likewise, different technologies will be used under the 5.0 standard, where the like the IoT operation will be handled by AI-based systems, and also these systems will be very human friendly, such that the human and machine communication will happen very smoothly. So, however, like cognitive technologies based Industry 5.0 is, I think, still getting, processed, and research work is still going on related to that. So, with regard to different, industrial revolution and industrial standards, that's all basically. When we consider about the industrial 3.0 and 4.0, we will be focusing, we will be able to see that the industry 3.0 is a computer system based standard. So industry 4.0 is a IoT or a connectivity based standard. So when we consider those two, like industry 3.0 and 4.0, we are able to say that the uh, in the industry 3.0, we will be having some, features, and in the industry 4.0 also we will be having some features. So the basic differences we will discuss. So the first thing is that the industry 3.0 is basically focusing on creating a certain product, uh, and producing during a certain period of time. So in here, in the industrial 4.0, the main target is to preserve the lifetime of the product. So the industrial 3.0 concerns about manufacturing products on time, while industry 4.0 also focus on manufacturing products on time. However, that will be done based on other like intelligent decisions, intelligent product manufacturing. So the uh, manufacturing process will be customized based on the different requirements from the customers, those of the available resources in the network. So in such kind of things, intelligent product manufacturing will be more convenient than Industry 3.0, like manufacturing method where you are just manufacturing some products. Rather than just manufacturing, maybe you can get some feedback from the network. Based on the feedback, you can adjust your decisions in a way that you can, give more quality of service to the customers, and also in the required time, at the required time. Then in the Industry 3.0, computer systems are basically used that can monitor the network, right? So they can, most of the time, they can do monitoring tasks. However, with the 4.0 standard, we have this, smart manufacturing systems where you will be having some connectivity to each of the devices, and then we will be able to do the communication based on data-driven decisions. So we can, add connectivity between all the devices in the uh, industrial uh, scenario, or in the industrial environment, we will have some devices. So the industry 4.0 is focused on adding connectivity to each of the devices, and then also enabling data-driven decisions, right? Adding connectivity and enabling data-driven decisions. So enabling data-driven decisions enable us to uh, take decisions based on like the data. So the Industry 4.0 will be focused on data mostly, They will be focused on data, and data-centric services will be provided. Whereas in Industry 3.0, they have focused on some targets by when they will be producing some product, and based on that, they will be do the production that will be it. However, like based on this Industry 4.0, they are proposing that based on the time the customer wants the product will be developed at that time, and then we will be using intelligent like product monitoring systems to deliver the product on time to the customer. So intelligent decisions are made with the Industry 4.0, while Industry 3.0 we have some static systems which cannot really interact with like a lot of components in the network. So Industry 4.0 is about basically enabling communication between every device in the network which is in the local area, such that the connectivity is prevalent between the network devices in the Industry 4.0. So with the Industry 3.0, we have these computer systems to monitor the environment conditions, and also with the Industry 3.0, basically the computer systems will be planning, and then computer systems will be used to um, execute the plans. So whereas in this Industry 4.0, we'll be basically making the decisions based on data-driven, uh, data-driven methods. So basically, Industry 4.0 is working based mostly related to data and obtaining some feedback from the data about the data, and then making some decisions on that. Which means that using data, it makes the decisions. Industry 4.0. Whereas Industry 3.0 will be making decisions based on the monitoring, like monitoring it had done in the static device. So most of the data will be in each of the device levels. So in that case, it's hard to really, know the entire view of the industrial facility. Each person will be like adding the data to the computer system, but that will not be shared with any other computer system. So with that kind of some static systems with no connectivity, it is hard to do the computation in an optimal manner, such that um, the entire facility is under the control of the user. So it's easy to manage manage an industrial facility which can be connected to the internet. Otherwise, if we cannot connect to the internet, and if we don't have connection with the local area network, then we don't have any idea about the conditions of the network. So in order for us to have that, we are using this IoT in the industrial IoT, and then that Industry 4.0 is a standard that utilizes IoT technology in the process, in the manufacturing process. Okay, so with regard to industrial IoT, I hope that is all I'm going to cover with regard to industrial IoT. So any questions up to that point, up to this point?